you see here,
Yeah.
okay? So we have what 1 hour difference. You see, 10 p.m. or 10 a.m., 11 a.m. Okay, and so for example, we continue to run. You can see 34, 35, 36, 32,
Like
42,
a big
45,
jump,
40,
right?
exactly. And at some point here, see, 11:56 to 12:26. See, that's the change of injector. Okay, so that means that all of these guys
Share
see,
the same.
exactly should share the same detector distance. Okay, so all of these share the same detector distance. Okay, so and here you see the run numbers. Okay, the data is going to be stored by run number. Okay, so that means that, for example, here you could use runs 18 to 20 can be optimized together. If we look at it here, 1226, see 1226 to here to 110, okay, to 1310. So that means 1226.
21 and 22.
Exactly, 21 and 22 can be optimized together. Okay, then and so on and so forth. Okay, so that's how you check the different injectors, and you run it in such a way that you know they're all sort of in the same bunch. Okay, so then if we go here, okay, as I mentioned, this here is all old data. Okay, so the first thing you need to do, let's do it simple. Okay, we take, for example, for true dark. So let's, maybe the easiest way is to do mkdir Karakri true dark. Okay, and then we go Karakri true dark, and then we do run 20 to 20. Sorry, what is it? 18 to 20, isn't it? So run 18 to 20. Okay. So then you go in here, and then what I'm going to do is I'm going to go out and go to, see, that's the way I had written it here. Okay. So then we can go to mmcpd2, let's say 23 to 25. Okay. And if we look in here, see, we have desktop, full index, and op param. Okay, so I'm going to copy everything, then I'll just delete the stuff that I don't need. Okay, and I'm going to copy everything through Karakri through dark. Wait, no, I'm not going to do it like that. So first of all, I'm going to copy everything here. So all the scripts that we have here. Okay, and we're going to put them into Karakri true dark, run 18 to 20. Okay, and then I'm gonna do mkdir dist opt. Okay, and now I'm going to go into dist opt and see what we have here, and see we can take all of this data. So basically what we need is the geometry and the Criswell split. Okay, so that file, and that's basically it. Okay, so we take cp Criswell split, okay, and the geometry, because the geometry is the geometry of the what's it called, of the thingamajig of the no, of the detector. So there is no difference there. You know what I mean? It's refers only to the detector, not to. So, and then I'm gonna take from here cd opt param. Okay, and see, now we have loads of files, but actually I don't want it in reverse because I want to see the old files. See, and so now I'm gonna copy. So I'm gonna make a file, and no, Karakri true dark, exactly, and this is gonna be called opt param. Okay, And now I'm going to copy SH into here. And then, so, exactly. And now we're gonna copy also the original geometry. Let me just check real quick. I want to see. Yeah, we're gonna copy the original geometry because if I remember correctly, the original geometry was better than the original, yeah. So cp ori.geom and so and this dot and up. Okay, and now finally I'm going to do crockery. No, oh yeah, I need to go on. MK deer, crockery, true dark, full index. Okay, and now CD full index, and then here, see, I copy CP crystal split into crockery true dark. There. And origin. Okay. So there we are. There it is. Done. Okay, so now we have all the files that we need. Now it's the time to look for the other files. Okay, so and now we can go crockery true dark. Now the other thing I'm going to do is mkdir sample folders. Okay, folders. And I'm gonna copy cp crockery cp, what is it, run 18 to 20, everything. And we copy all of this within sample folders. And so now in sample folders, basically you just need to copy this whole thing somewhere else and it will just make everything, isn't it? So you don't need to move it back and forth or anything like that. Okay, so the next thing you need, of course, is you need two things. First one you need is a file containing the unit cell of thingamajig, isn't it? So, and you also need a list file containing all of the images that you want to process, isn't it? So, okay, now where do we find this? This we find in, let me see, cd does, if I remember correctly, no, where was it? Let me just go real quick out of here, and we go to P21006. So it's here exactly. And where are we now? Exactly. No, this is not it. We want to go to was it raw? I think it was raw. Yes, exactly. There it is. Okay. So so now here, of course, we're looking into runs 20 and 21, isn't it?
Mm-hmm.
So
Yeah.
now if we go to 20 and 21, so we just need to go run
Or 18 to 20?
18 to 20. So we go to 18, for example, and here, raw data, was it? No, not it. No. And then it wasn't in raw. Was it in res? Let me just check real quick. Yes. Yeah. So run 18. Okay. So notice where we are now on the res. Okay. And so if we now look here, we can look into indexing. Okay. And in indexing, you have all of the data, but the most important thing that you have, if I remember correctly, where is it? This is only the. Just check real quick. Okay, let me just check real quick on the, because this is just indexing. Okay, let me just go back home, and I want to check on the full indexing that I did at the time to just check on where the files are. Okay. So, where is it? Okay, proc, full procs, and then I go MMCPD2 23 to 25. Also, let me just check one thing. Okay, I want to check first here. Oh, well, it doesn't matter. 23 to 25, and now opt param. No, param. This opt. More h5. More all.lst. Here we are. So. Okay. So where is all of this data coming from? Because it used to be that. Okay, let me just go here. Now we look into work, maybe? No. Work is this. Then raw. So what I want to look is into the list files that were used for this. You see? So because it had produced files already. Data. Yeah, I think in here. Yeah, there it is. See, we have list files here. Okay, so what that means, so notice where you have to go. SF Alvra, okay? So on the run and all that, okay? So SF Alvra, PU21006 /raw / the run you want to use, and then data, okay? So now what do we do here? Well, we go back to P2106 proc, full procs, crack rate through dark, what's the name of it? Run 18, detector, this opt, okay? And now what we do is we do cat all of this, okay? star.lst all.lst, okay? And now let's check that it is a big file. Yeah, 4.2 megabytes. If we look here, these are about 390 kilobytes, okay? Now, the other thing we need to check is how many images we have here, okay? So, and you can see, so this is how it looks, and then we do grep -c, and we count how many images we have here, just by counting the number of lines that says this. And so here we have 54,614 images, which is not, it doesn't mean we have 51,461 crystals. It's whatever the indexing rate is of that. But you want to have a couple of thousand in them. So when we look into the script, okay, so this crystal script, okay, see, to process a batch of very fast, that's not what we want here. That is not the file that should be here. Remove crystal split. This is not the one we want. CP. Let me just check real quick. Should be MMCPD2, and then in MMCPD2 we take any one of them, 179 to 180. See, clen test, so we copy it from clen test. Okay, and we copy all of the PY files. Okay, and PSH files. And is that all of it? Yeah, what's that? So now we have everything in here, okay? And so we'd go to the one I can never remember. Is it distance scan analysis, or is it exactly. So path to top folder, either course or fine. No, this is not what we want. And let's see what are more crystal. Yeah, distance scan. Which one did I just look at? Yeah, detector distance refinement. I think it's that one. Exactly, this one. And see, now there you have it. -L, path to the LST file generated by DAC, -G, path to geometry file, -D, central clen to refine around, -C, self file, -S, sample size. And the sample size is the one that determines how many images are going to be looked at. So for example, we can say 10,000 or 5,000 or something like that. Okay, so the first thing we need is a geometry. Okay, and to get a geometry, okay, so the other thing that I'm going to do, by the way, is copy all of this into the sample folder. Okay, so that it's as it should be. Okay, and now what we're going to do is we're going to take, okay, this, and we're going to go for, so we need a cell file, isn't it? And so the cell file we should be able to retrieve from any of the so let me see, more all.lst. So here we have it, and then ls, actually it's easier than this. CP should be easier at least. Crockery true dark. Crockery. I don't know. Is there a dark one? No. Let's go 1 nanosecond. This one. Okay. And crockery cell. And we copy it here. So now we have a cell file. Okay. Okay. So now we look again at distance scan analysis. Okay. No, sorry. Detector distance refinement. Okay, and this is the way we write it. So Python, and then detector distance. Okay, -L all.lst. Okay, -G ori.geom. Okay, -C crockery.cell. Okay, minus S, let's take 10,000. Okay? And minus D, I can't remember it. So let me just copy all of this first. I can't do it. Okay, let me just go for the one below. LS MMCPD2, and then we go to any of them, 179 to 180, clean test, okay, and course, exactly, and we want what, 0.0932 is from 0.087 to 967, so yeah, 0.0922. Okay, so we can take a look actually here, okay, and we can look into index all, okay, and we can go to more start.stream. Index light. Okay. Index light. Why isn't it there? Shift 1. Yeah. Shift 1. And now all.stream. Where is it? Origin. Okay, great, no problem. Ori.geom, and we see 0.0922. So that's what we use as the middle point. Okay. So we go like this, and we go distance detector distance refinement. Okay. So just to get that again, Python detector distance refinement minus L all.lst minus G ori.geom minus D 0.0922, wasn't it? We had it up there. Where was it? Here. 0.0917. Okay, 0.0917. Also okay. So we can take that one. 0.0917. Okay, and then minus C crackery.cell and minus S 10,000. Okay, and we start it. Module this was come on. History grep minus E module. Let me see here. Module use mx module load crystal da. So that we have crystal here. Module load Python 319. Okay. Module. This is to have all the software that we need. So running. Okay. So this should work now. What do you mean unavailable? Do you see pandas here? CUDA, MATLAB. Okay, let's try and run it again now. Christville all out. Okay, so it didn't do anything. So let's run it again. More. I fucking hate this, really. This thing really. Okay. It should be in Python. Okay, so. Let's see. Okay. So maybe we should go and get that. So to the meeting, but maybe see Python Cinemajig module load. Now, is it working or not? What are you doing? Let's see. Foreground. Still doing nothing. At least it's an improvement, at the very least. But not saying, there it is. Yeah. Okay, done. So it worked, okay, and so now we have course in here. So and we can look into course. Okay, and then in course we should have one folder each for this. Okay, so for each detector distance, and we should be able to open one of them. Okay. 9, 5. Let's go for 917 because that one was the one that we enjoyed, wasn't it? So the one that we suppose would be the best one. So now in here we should have, see, all the file, and we have an index file being produced. So we can actually, so a stream file. So we can actually run indexing rate on it and see we're getting about a 14% indexing rate on this. Okay? So this is going to continue running until this one reaches 10%. And then, we will have all of it. Now, if you think about it, if our indexing rate stays at about 15%, okay, that means 15 out of every 100, that means 150 out of every 1,000, that means around 1,500 images by the end of this optimization, okay? So now, once this is run, so let's go to the meeting, and then after the meeting we can continue, because at that point we should have some information, okay? This, and then SQ. So this command here will tell us how many jobs are running in our queue and what kind of queue it is running. See, now we have all of these ones running, okay? And you can see that we have these ones here waiting. So PD means waiting. R means running. Okay? And so these ones are running, and they're running on the day queue. That means that at most they will take, at most the system will allow them to run for 8 hours, which 8. So that means that they should be able to run quite a bit faster after this amount of time. And so by the time we're done with the meeting, this should be done, and then we can take a look at the next couple of steps. Okay? But so with this, at least now the detector distance optimization is running, and so you can do the exact same thing for every other injector. Okay? So that we find the best distance for each injector. Okay?